Ladies and gentlemen, welcome to the 8th edition of the Brazil-Korean Forum. My name is Rodrigo Higg, and I am one of the coordinators of the Brazil-Korean Forum. At this moment, I would like to thank Professor Dhananjay Singh for accepting our invitation to participate in this event. Unicinos has elected South Korea as a strategic partner, so maintaining a partnership with dozens of institutions in that country over more than 10 years. In this way, the Brazil-Korea Forum is a traditional international event that celebrates the partnership of research, science, and innovation between the countries Brazil and Korea, together with other partners such as USA and Germany that have joined us in cooperations over the time. Since 2011, the Forum has been active in the education and training of students and professors, so focusing mainly on the topic of semiconductors and its extension to Internet of Things, sustainability, and healthcare areas. The partnership between Brazil and Korea is fruitful and has already resulted in the creation of the Semiconductors Technological Institute at Unicinos, as well as in a close academic mobility at both undergraduate and postdoctoral levels. In this year, the Forum Brazil-Korea takes place entirely in a virtual mode through a cluster of workshops and panels. So at this moment, I would like to invite all participants to watch a short video of the main achievements of the Brazil-Korea partnership.
Com sua primeira edição em 2011, o Fórum Brasil-Coreia consolida uma parceria de quase uma década entre Unicinos e instituições da Coreia do Sul, com o principal objetivo de compartilhar conhecimento entre pesquisadores na área da tecnologia. O evento estimula a inovação e desenvolvimento de produtos. Desde sua criação, o Fórum teve como principal tema a cadeia de semicondutores. A partir das relações criadas entre os países com o protagonismo da Unicinos, a área se consolidou com a instalação da empresa HT Micron no Tecnocinos. Ao longo dos anos, o Fórum possibilitou diversas oportunidades para a comunidade acadêmica, desde publicações científicas conjuntas, ações de mobilidade estudantil, dupla titulação na pós-graduação, projetos de pesquisa no âmbito da indústria 4.0, até a capacitação de recursos humanos para o setor tecnológico. As conquistas do Fórum Brasil-Coreia se ampliaram com o tempo e mudaram parte da matriz econômica da região. Além do estímulo às startups na área de saúde e tecnologia, o Fórum possibilitou a criação do Instituto Tecnológico de Semicondutores ITT Chip, a partir dos programas de pós-graduação em Engenharia Elétrica e Computação Aplicada. Em 2019, a integração entre pesquisadores brasileiros e coreanos, ITT Chip e HT Micron, criou um marco importante para a área no Brasil, primeiro chip semicondutor para o mercado de internet das coisas projetado no país. Perspectiva de uma expansão e consolidação das suas relações internacionais, Unicinos mantém uma contínua ampliação do Fórum com a participação de países como Estados Unidos, Alemanha, Austrália, entre outros. Movimento estratégico que torna o pioneirismo uma tradição, fazendo da inovação uma cultura que a Unicinos, universidades brasileiras e coreanas, ter público e empresas constroem, agindo localmente e pensando globalmente.
So, at this moment, we will start our event and we will have a workshop between two great universities. So we are receiving this moment Professor Dhananjay Singh from Hankook University, and from our side, we have the Applied Computing Graduate Program at Unicinos. And well, welcome, Professor Dhananjay. Good morning for our audience in South Korea. Good evening for our audience here in Brazil. So we will have a workshop today in this evening. So the idea, Professor Dhananjay, is we will have close to 30 minutes for your presentation. So we have the same time for our presentation. In the final, we have a discussion for further collaboration. So again, it's a pleasure for me. It's a pleasure for our team to receive you. And please welcome, share your presentation with us, make your introduction.
Thank you, Professor Righi, and thank you very much for inviting me and giving me opportunity to deliver a talk at this our long-term collaboration Brazil-Korea Forum. As you already mentioned that we have 10 years collaboration now in this topic. So today what we are going to do that we are going to introduce our recently project, what we are doing, and then what kind of project we can collaborate in future. That would be our next target. And then also I will show our joint results, what we achieved last 2 years, right? So first of all, I am Dhananjay Singh, an associate professor in the Department of Electronics Engineering at Hankook University of Foreign Studies, Seoul, South Korea. We are working here mainly the Internet of Things related solutions and technologies we are building in our laboratory with the team members. So today I'm going to introduce our research projects. And before going to introduce the research project, I would like to introduce our laboratory, that is the research lab. We are working the future internet architecture, Internet of Things, blockchain technology, and also we have very strong collaboration with our industry partner, that is the M2V and Vestela. To this industry we started together. Actually these industries started from our lab students, and then it's about 7 years we are working industry and university collaboration project as well. And also I'm the distinguished member of ACM and senior member of IEEE and ACM Society. So recently we have started this is our blockchain stack design which we use to develop the technology. So first of all, you can see the first diagram. It is showing the IP based blockchain network. If you see the diagram, there is the IPv6 network, and gateway with AITT is the adaptation identifier tier. So in this one we can connect with and this one is cross layer based IoT platforms, where we can use this platform to provide the autonomous areas platform, where we can connect several services for IP based small embedded devices. So we have implemented this stack over the Kontiki COSA simulator. So, and also we tested this whole stacks based on the IP based low power wireless personal area network like 6LoWPAN. If you see here, we do the adaptation identifier layer. So what we did that we use the IPv6 based low power wireless personal area network implemented over the adaptation layer, and adaptation layer work for the application and services. So this is our very strong stacks which we use our most of the applications. And here another one is we use for the software defined radio for the directional antenna. As you know that we use mainly the cross layering application. So here we change the spectrum, and then over you can see here physical layer we divided like this, and MAC layer we use for the spectrum sensing and also channel allocation for the over the MAC layer, and network layer we go for the hop direction, like next hop and first hop we use like that. And then application layer again we can use for the particular applications. And this one is our the semantic web based solutions, where generally we use this kind of computing power over the ontology like cloud system. So these for three mainly the stacks which is based on our technology development. So let me go very starting briefly introduce our project. So this is the project which is funded by our Hankook University of Foreign Studies. So in this project we use for the healthcare for we given the just name there. So what we do that we have designed the blockchain architecture here. In the blockchain architecture, where what we try to do that we try to divide the healthcare system in the three parts, what we call that the patients, client care, and clinical care. So these three divisions, what we do that we use the traditional healthcare architecture. Then we connected the healthcare 4 architecture, where we make the three layering, and then three layering we combine all the medical facilities for the patients and the clients care and the clinical care also. So this one is basically we use for the improvement of the trust and traceability on also the supply chain solutions, especially the the supply chain solutions is also very important for the medical drugs supply from the factory to the patients. The whole history we want to record it as well. So this is also come up under the healthcare 4.0 project. And then this is our architecture where we use for the decentralization and data management system as well. So this is the just architecture. And then after one by one, I'm going to introduce the healthcare related one project. This project we using for the gastrointestinal tracking diagnosis system. So what we try to do that we are trying to design one device which can have a power to it's also again IoT device. It can we can easily fix over our stomachs and the body, and then based on that they collect the abnormal activities inside the stomach, and then after the doctors can predict what kind of disease and problems in their stomach going on. So what we do that here, as we know that the constipation is the very big issue for the lots of the people in the world. So especially the old age people, this kind of, so if somebody has this kind of major issues, so they have to visit to the hospital, and then doctor use their equipment, and then they check what kind of constipation and how much gas in their stomachs. So what we try to do that we try to make the IoT device which is easily to fix by anyone in their patient's body, and then after the real-time data can using the Bluetooth communication medium, data goes from the body to their smartphone. It goes from using the smartphone, it goes to the cloud server. So this whole communication medium use the blockchain technology as well to make secure for a specific or particular patient's information. So what we do that we would like to develop a non-invasive diagnosis gastrointestinal tracking device, which is based on the Bluetooth and cellular network communication technology, which is utilize the EGG. EGG is electrogastrogram signals to identify any form of abnormalities occurs inside the stomach of the patients, and also evaluate the results based on the magnitude of the frequency of EGG signals. So then those EGG signals recorded from the patient's body, patient's stomach as well. Then all collected results what we go we transmit using the Bluetooth and wireless cellular network channel to the doctors or the patients on their smartphone, and also forward those data to the cloud server, so where doctors or the respective persons can check and then predict or they guide their patients what kind of medicine they have to cover. So this is the project, and this is the process how the whole system works. So what we do that here we use the sensors on the body, and then use for the amplifier signaling. So this whole process we collect data over the Bluetooth module, and this is the web app, mobile phone where we can access it, or we can transfer the data from here to in this place. And then once data goes to the here, so it will start using for the blockchain network over the communication medium. So as you know that blockchain we use the smart contract, and a smart contract has connection with the cloud server, so it also works like plug and configure for the system. So easily all patients data can the configure with the blockchain system to the cloud server as well. So you can see here what we do that we use the 3 points. So EGG signals filtering for high pass filter, and then also we use the signal for amplification over the microcontrollers. Then microcontrollers is associated with the mobile apps, which is using for the smartphone device as well. And then based on those data or the signals, they can predict what kind of disease the patient has as well. The EEG signal noise filtering has considered two band pass filter and a differential amplifiers, and also RC low pass filter has ability to eliminate the noise from the signal obtained from the GIT, like gastrointestinal tracking device, via EGG electrode. And also microcontroller is used for the internal process and collected data for the enabling systems and connect with the processing unit as well. So let me show you very quick the what kind of channels we have considered for this. So we have considered 4 channel here. One is the for stomach, and then skin intestine, then this is the frequencies given, the frequency range, how it works. And this is the portable device, what you can see here. So we can fix this the point, 3 points over the stomach, and then after this is the just signal what we got. We say that the outputs comes from this these devices, and then what they do that perform the measure for EGG measurement devices from this. So we tested this result as well. So EGG signal is the simple sampled rate is 100 times per second, which is a 5 times minimum sampling rate, but we can using the Nyquist algorithm, but we use for the 100 times per second and implemented over the over sampling for that. And also this allows to use for the simple digital filtering methods, for example casual movement averaging for low pass filter and medium filter to eliminate the impulse noise as well. So this is the one project which is the IoT based gastrointestinal tracking device which we are trying to build in our laboratory. Another one we also try to use for the CCN network for the global healthcare monitoring. What we try to do there in this project, we use the content-centric networking technology to collect the patient's data from the factory or their home. So this kind of systems we want to build, and as we know that CCN network is very strong for the security purpose, and it also targeting for the specific data. So what we try to build here, for example, this is the hospital, and also these hospitals has the CCN network connected, and there are the office worker, and this office worker is the factory which before entering the office they want to work. So what they use for that, they use the variable jackets that devices the basic the temperature, ECG and EEG signals inside the inbuilt in these jackets. So the real-time basic data will collected each patient before entering to the factory, and then transfer to the whole CCN network to their cloud server every day. So based on that, the factory manager can also make decision for the insurance, and then they can decide which worker has to go for which he has to work or he need leave for the working during the. So there are lots of the big factories. There are lots of accidents going on because of the poor health condition. So with this system, we can track their person's health condition as well. This is the process how CCN whole networks work. So this is also global test bed, which we can say this one client one we called that. This is the variable device, and then we tested the CCN network for the core routers, and then this is subnet network, and also this one is the nodes. So whole system can perform like that. This is the overview architecture. What we made that we used this architecture, like this one is the office. We use for the tracking device like a smart device, and the office worker this kind of CCN with healthcare proxy, and also we use here the neighbors discovery protocol, and also we use for the data visualization protocol. We combine both of them to find the health care data management protocol to collect whole data over the aggregate healthcare aggregate server. So what we do that healthcare aggregate server making the records. If some emergency case come up, then it's the pop up those information and directly can associate it with the hospitals and doctor, and then they can get result to their factory worker as well over their smartphone as well. Similar situation we have connected with the smart home system. So smart home also, the person, if somebody is taking this kind of variable device, so he can use same network, CCN based network, to collect their data from the home, hospital, and the movement pace as well. So doctor can also, because these all systems are associated, and these are the portable systems. So we can see here the doctor can have a render at their home or hospital. Anytime they can monitor the patients and make their decision as well. So this one is another healthcare solutions. Two and one, we are also working for the drug supply chain. I didn't include that one project because this project we have just recently applied with the European government, and the project is called the supply chain drug supply chain management system. Like what we do that this comes also in the healthcare 4.0. So what we do that we make the blockchain network where the network will associate it with the drugs factory, and then the patients who is going to use that medicine. So it will track the each and every movement from the factory to the patients who is consuming the medicine. They all track record. So we are making another project for the supply chain solutions for the healthcare industry as well. So this one is the healthcare related projects which we are working on recently. And another project we are working for it is from the Ministry of Hajj in the Saudi Arabia project. So what we try to do here in this project, we are trying to understand the bus data from during the Hajj period. They have a lots of bus consider for the local transportation, especially the Makkah city in Saudi Arabia. So they provide us those data, bus data, all data records, and they wanted us to study those data to predict them and provide them the solutions. So what better service they can use for the transportation as well as the food and support for the all pilgrims for there who is visiting the Makkah during the Hajj period. So that was their whole concept. That time they provide, each bus has AVL GPS based data technology, so which we can use here. We can see here GPS system. So they collected all AVL sensors data, and then they give it to us the sensors data from there, and then we are working last 2 years in this project. So the experimental done. So what we did that we use the pattern analysis system where we process the AVL GPS based data, and also we use the features extension, and then we predicted the data visualization concept we use for the unsupervised learning for this. And then we use for this is the bus data, like you can see 100,000 into 8. Then we use this sampling rate, all bus 421, 4,210 from the Hajj 2016 bus data. And then also we calculate the journey, this whole system or journey based on the distance each bus, and analyze the speed, long route and short route buses, and finalize the finding the congestions, bottlenecks points in those route as well. So this is the process. The parameters, we consider those parameters to provide them solutions on that. So we have several results based on this analysis on the pipeline. Our team are working on that. So I just wanted to introduce this project as well, which we are funded by the Saudi Arabia Hajj Society. And another project, this one is based on the blockchain enabled mobility data collection system. In this project, we are working mainly for the vehicles data mobility pattern. So what we try to do that, as maybe most of you already know that during my visit in the Brazil, we talk about the connected vehicles a lot, previous my lectures. So now what we try to do that, we use the connected vehicle technology. So what we try to do that, We build our one cloud server, blockchain cloud server, to collect all vehicles real-time data. And after analyzing those data, we provide the solutions to the drivers, as well as we provide solutions to the manufacturer company as well. So what we try to do, that we build big cloud server where the persons who is driving, so their real-time driving behavior will be stored, and then after study those information, then we can predict the solutions for that. So in that case, what we have, the vehicle with the device that we call that Internet of Vehicles is connected here. And also we use the data apps where we can see the real-time status, driving behavior as well. And then driver's status, like he's the how over speeding, how fast he's changing lane, all study done by the uh, collected over the, we have our own stack platform, we call it like that. So this is the stacks, like here the drivers and vehicles are collecting real-time vehicles data, and that data is we can collect using the mobile device. Also we can use the variable device to collect this information. Then after the authentication, then machine learning module will have the processing, the classifying those information. After the classifying particular applications related to the vehicles, they use for the channel also for, and then they distributed to the storage system. And then after the Vestela blockchain we use for that system to produce the vehicle data market platform for the customer. So what we said, that we provide two ways of supports. Which one is the drivers, he want to study his driving behavior, and also we provide this to especially for the insurance companies. So insurance company make decision, so they can provide insurance, next year insurance is the discount, or they want to continue in same price, like that. If he is very nice drivers and he is properly following the system and rule, so insurance company can give him the discount for based on the his driving behavior. So this one is the data for the blockchain based networks for the real-time vehicles collection data. And as we just mentioned before that, this we collected over the OBD2 devices, and also we use the smartphone devices variable where we collect real-time vehicles data as well. And also we can analyze the real vehicle status data, which includes current status like battery temperature, engine temperature, fuel efficiency and quality, and also vehicle purchase and sale record. They maintain information regarding this. And also the driving history, the data of vehicle during the operations, and location data of the vehicle in the motion during the movement period, exact location where. So these all have real-time tracking record and information they use for that. And this is the driver behavior. So what we did, that one is the vehicle status data, another is the driving history data, and third one is the driving behavior data. So we make categories and then we store this information for that. And this is very useful for the both person, like for example the customer who want to use the technology, they want to get some rewards during their parking lot system or during their gasoline station, so they can get the rewards for that. It is also connected, so everything is very secure for the safety of the vehicle as well as the driver safety as well. And also the data market, they can use those real-time their driving vehicles data to sell, and then they can make the money as well for that. So these are the mainly purpose why we connected for the blockchain technology over the vehicles. And as we just mentioned, that the rewards of the data provides for the selling purpose during. And as I just mentioned that we once you use it, the system, you can get this is the digital coin we called VIII coin. So VIII coin can obtain simple providing the driving status and location data. So the basic data, if you are providing to the server, so they can get the point, and these points can use during the parking lot as well as the gas station as well. And another one is the artificial intelligence based the architecture will use or utilized for the blockchain technology for the consistently for increasing the value of the reliable data information as well. And this is the just the OBD2 based car market, taxi and car repair shop, like these peoples can use this kind of services. And also the real-time smart driving assistant services, that components smartphone, wireless OBD scanner and cloud server. And basically it is supported for the safety as well as the smart and eco and also fun driving, because you can share your information, all status with your friend, so they can also observe what kind of your driving behavior and everything. So this is the our generated algorithm solutions. So they consider this kind of the information from the vehicles, like engine load value, freezing DTC, engine coolant, temperature, short-term fuel, long-term fuel, fuel processing, and threshold, and throttle position. So these all parameters we consider to provide these solutions for that. And all, as I said, all sensors, this all sensors data is comes over the OBD2 scanner port, and then this real-time driving coaching behavior. So so they can also have solutions, and driver get to know how the driving behavior over the over speeding or lane changing, so they can get instruction from this whole algorithm and software as well. And also engine sound equalizer will support them a lots of services as well. So over the customized web app, so they can see the how much efficiency they are using particular things. For example, how much they are giving the load over the engine, and how much safety and security, this kind of all parameters they can analyze over the smartphone and monitor screen. And this one is showing the sweet spots. These are the basic parameters we consider, and after the considering these parameters, we compare two situation. One is this is called that sweet spots, and this one is the rough driving. So if somebody is driving very roughly, and so how much expended, their engine quality, gasoline, and all cost will be after the finishing their driving, or we can also have monthly records. So based on that, they get the certificate, how much they drived in this month and how much money they have expended based on engines, gasoline, like the how long they have traveled. And this one is the person who drove very nicely, and that based on that he also gets certificate. So those certificate after 5 to 10 years, if both of them want to sell their vehicles, so they can get benefited from, like this guy has 10 years very nice record, and this guy has 10 years very bad record. So based on that, his vehicle cost getting low and his vehicle cost getting up because of the same time during the buying condition. So this is the main purpose why we provide these whole solutions for the second-hand car market zone as well. So this one is the Internet of Vehicles related then project. And now I would like to introduce, like we have a long collaboration with Unicinos team. So in that team we have like we started especially 2014 until now. So this is the currently we organized several workshops and the conferences. So these conferences, like just Professor Righi was introducing, like a human computer interaction, ISCI. It's major conference which is running last 12 years. So it was last week. So where Professor Righi was the speaker, keynote speaker for this conference, and he delivered very nice talk the morning session. And also Professor Righi was joined. We organized the one Internet of Things 5G forum, where also Professor Righi was the technical committee members. And also we joined organized the workshop in the Denmark last year. So where was the workshop was future internet model for smart city services. So we was the chair and technical committee chairs for these three organizations in the last 2 years. We have organized that. And also we have published several papers. This is the one book chapter was published by the Taylors Francis. So this is the Nova Genesis architecture based, and the book chapter, and the one SCI paper we published like elasticity ran. And this is the published over the Computers Communication Journal. It's quite good journal as well. And we had two conference papers. One we published like the IoT, Internet of Things, big data and cloud computing. This was conference was in the Portugal, and also we published one paper for the cyber physical surveillance system for the Internet of Vehicles, which was the IEEE World Forum Internet of Things at Singapore. So these last 2 years we collaborated several results, and we organized several events as well. So this I would like to introduce all of the team members, both sides, to know how we are actively participating and working together to produce some good result. And this is the recently where I'm the part of the editorial board. So there are the PLOS One journal. These all are the SCI journals where impact factor 2.7. So I'm the editor of here, sensors and electronics. So in our upcoming results, and there are the several special issues. All of them are the SCI based journals. So in our future like collaboration, we are planning to publish our results here as well. So if we would like to invite all the participants who is listening today. So if anybody has interest or research work based on this topic, so they are free to apply here, submit their papers, or we can further collaborate together. So thank you very much. This is my side, which I just wanted to introduce at the short moment. And if you have any queries, any question, we can keep discussing, and I can give you your questions answer as well. Thank you very much, Professor Regi. Thank you very much.
Thanks, Professor Dhananjay, for your wonderful presentation. It was a great talk for our audience. And well, thanks for presenting our collaboration in detail. So thank you very much. So following our protocol here, we have the presentation from our side, Unicinos team from the Applied Computing Graduate Program. In this moment, I will share my presentation.
Okay, let me stop my sharing, I think.
Yes, please, Professor, share your presentation, so I will share mine. So can you see my presentation?
Yes, we can see.
So let's start. So here at Unicinos, we have a group named Software Lab, Software Innovation Laboratory. So in this moment, I will talk about some projects that we have, some achievements that we got during the last years. So our Software Lab is a research group, especially focused on health informatics, Internet of Things, and resource management. So we have research for more than 16 years, considering the scope of applied computing. So we have more than 30 softwares registered and patents along the time. We are an interdisciplinary team working with mobile and ubiquitous computing, and so we have working with students. So here we have a number. So, but this number is much larger. So here we have 200 students. Well, in this slide, I would like to show our partners. So in the top, we have some companies that are known worldwide. For example, we have Siemens, Dell, SAP, and others. So in the middle, we have the hospitals. So the hospitals are very important for our research today. So we have here the main hospitals in the metropolitan area of Porto Alegre. So Porto Alegre, for example, is the capital of our state here. And in the bottom, we have funding agencies and universities that we have collaboration. So considering the main areas of actuation, so we have, for example, we divided our work into 5 main areas. Well, the first is Internet of Things, artificial intelligence, the second. So the third is distributed applications and cloud computing. Mobile computing, context-aware computing is the fourth. And finally, we have the healthcare applications. My idea is to present you some details, especially focused on Internet of Things and cloud computing and healthcare applications in the next slides. Well, so in the next slides, I will present mainly research focused on research on health informatics area. So we have a project together with the Siemens company and together with the FAU University. And the main idea here is to combine data from sensors, real-time location systems, for example, UWB or RFID, right? And also with data from cameras, RGBD cameras. And so combining these both kinds of data in order to improve the workflow in a hybrid operating room. For example, can you imagine a surgery that can take longer than 60 minutes, for example? So our idea is to optimize the way of the physicians and the nurses in this surgery room so we can optimize this time, for example, for 50 minutes. So we can reduce the time and we can optimize the workflow in the hybrid operating room. That's our main idea here, so working with sensors. And also, we have research on rethinking the idea of a room in the hospital. So our idea here is to take all data from the patient, all data from the environment, from the bed. So we are combining this data and storing this data in a blockchain. So we can get this authenticated and immutable data at real time. So and to deliver this kind of data to physicians and nurses, for example. And also, we are working on this project on the idea of combining a lot of information to produce an intelligent risk score tool. So here we are working with big data and data analytics. For example, here in this particular research, we are working with random forest in order to predict the problems that could happen with a particular patient in this future operating room, not operating room, but future hospital room. So here, joining the idea of healthcare and health records together with blockchain, we have our research here. And so this research, we have a partner that's a hospital named Hospital de Clínicas. That's one of the main hospitals in our capital here. And also this project is founded by CNPq, that's one of the main agencies here in our country. So we have data from the patient and we are storing data from the patient in a distributed network, so storing data in a blockchain format. And also, so it's very important to emphasize that today at Unicinos, we have two main international projects. So one international project named CAPES Print is project of internationalization. So CAPES is also one of the main funding agencies here in Brazil. So one of the projects is focused on Internet of Things and healthcare areas. And one initiative inside this project is to provide a good quality of service for applications. So here we can imagine a hospital for the future. So you have the use of Internet of Things and machine learning in the benefit of people's health. So in the top layer, you have the applications, so you can have a lot of applications, each one with a particular QoS requirement, quality of service. In the bottom, we have sensors and actuators from many types, and in the middle, we have our middleware. So we can adapt our middleware at runtime, for example, with data compression, so with jitter adaptation, with cloud elasticity, in order to provide at real time a better quality of service for each application. And also, in the scope of healthcare application, healthcare research. We have a project named My Digital Health, in Portuguese, Minha Saúde Digital. So here the idea is to use a blockchain-based intelligent model for health information and patients interaction in the scope of COVID-19. So that's our main idea here. And it's important to emphasize that we have the main regional hospitals acting together with us here in this research. So the coordinator in particular of this research is Professor Cristiano Costa, and it's very important to emphasize that this project was elected as one of the best proposals in Brazil. So the second part of my presentation, I will go toward explaining research on computing resource management and architecture. So my main idea here is to talk about details about our development on Internet of Things and Industry 4.0. So in this slide, okay, it's a healthcare project, but here we are using cloud management, and in particular here we are using cloud elasticity. So, okay, talking about the Internet of Things system, in one side we have the sensors and the actuators, in the other side we have the application, and in the middle we have all the infrastructure to run the application. So in the middle we have load balancer and all services that run in the middle. And our idea is to map these services inside the virtual machine and work here with cloud elasticity. What's our final purpose here? Our final purpose is to provide scalability for our applications. So we can enlarge the number of sensors and we can enlarge the number of applications at real time without problem because we can adapt our middleware. So here one research the scope of precision agriculture with data prediction. And here, basically, we are combining Internet of Things sensors and actuators together with the LoRa wide-range communication. For example, our prototype includes a solar plate, arugula crop. So we are deploying particularly in an arugula crop. We have also sensors connections, of course, Arduino board. As I said, we have a LoRa board, and joining all of these, we have a battery. So, as I said, we have research in the scope of Industry 4.0, and here we have our second print project that's mainly focused on Industry 4.0. And inside this print project, we have a collaboration with a company named AGT Micron Semiconductors, and we are deploying all our experiments on this company. So in this slide, we can see two major things. In the left, you can see our main idea and comparing reactive and proactive approach. So in the left, we have a reactive approach. So after crossing the upper threshold, you will take some action. But this, in the reactive approach, it's possible to have a problem because only in the green bullet you will take an action really. So in the right, you have the proactive approach. So at real time, you are collecting periodically data. So you are combining this data in order to get a prediction. So it's possible, for example, to use random forest, machine learning, moving average, ARIMA, and so on for this kind of prediction. And here in the proactive approach, the idea is to use this data to predict some problem, so taking an action beforehand. And in the right, you have our main screen of the project, so considering the types of the sensors, and mainly we have three main types of sensors considering environment, machine, and process. And so at real time, we are collecting data from electrical field, particles, humidity, pressure, vibration, sound, and so on. So For example, in the company, in the HT Micron company, we have more than 200 sensors installed in the clean rooms of the company. So in this slide, my idea is to show our board that we have developed in the Semiconductors Technological Institute at Unicinos. So considering our architecture, we have an integration board, and then we have a lot of sensors, and using wire, you have a connection from one sensor to this integration board. And here, we could use a Raspberry Pi, or we could use an Arduino board, but both Arduino and Raspberry Pi, they are not reliable for us. They are not reliable for an Industry 4.0 scope. So we have developed our own board, so connecting up to 16 IoT devices, both analog and digital devices. And in the right, you have a map of the company and, well, some points that we have installed the sensors and actuators. And here we can see the main dashboard, that was exposed by a visualization tool named Grafana. And for example, we can see the status of each sensor at real time. And so here we are using different colors for each kind of sensors. And it's very important because this system is used in the company in this moment. And in the right, you have an organization of the project. So it's very important to emphasize two main things in this figure. The first is our hierarchical organization. For example, why using a hierarchical organization? From one side, you have the client-server communication, but this kind of organization, client-server, is not scalable. So in the other point, you have the P2P communication, but this kind of application, P2P, it's not easy to manage. So in the middle, we have this kind of organization that we named hierarchical. So the other important thing to emphasize here is the communication from the integration board up to the concentrator. So we are using a board because this communication from the integration board to the concentrator happens through radio frequency. So we are using a board that can enable us to change the communication protocol at real time. For example, in the lab, we are using Bluetooth Low Energy, and so Bluetooth Low Energy has a good performance for us. Okay, in the lab, we selected this technology, but in the company, we could have another reality. So it's very important to enable to change the communication protocol at real time in the company. So, for example, we can change from Bluetooth Low Energy to 6LoWPAN without problem at real time. And here, a presentation of a slide considering the research in the microservices application. And so here, our research that I have presented in the in the conference that Professor Dhananjay was the chair some days ago. So our idea here is to combine cloud elasticity in order to optimize both energy and performance on microservices application. So we have mapped each microservices, and for each microservices we have a load balancer, and so this load balancer is in charge of controlling the number of replicas that will attend a particular microservice. So we can enlarge or we can reduce the number of replicas at real time. So here it's important to emphasize that we are talking about the number of replicas for each microservice. And also a research in the scope of cloud elasticity. So our group here at Unicinos is pioneer on delivering research in the scope of cloud elasticity. And here we have, as I said, cloud elasticity, IoT applications, and blockchain. And considering these three technologies, we have developed a model named elastic chain. So in the bottom, we can see an example where we had three nodes, right? And so these nodes are overloaded. And the main idea, okay, at runtime, we can allocate one more node in accordance with the application demand, so we can balance the load among them without problem. And here, well, very applied research combining data prediction, IoT, and milk management on dairy cows. So in the middle, we can see our real deployment considering milk sensors and controllers. So the idea here is, in accordance with the milk sensor, we can manage the amount of feeding for a particular cow. That's the main idea here with this research. So we have a connection between milk and feeding. And in order to control the amount of feeding, consider we are collecting milk data. So we are applying data prediction on milk data, so controlling the feeding actuator based on that. So considering the scope of smart cities, we have research on driver assistance in order to avoid rear-end collisions and also to detect potholes in the street. So in this research, our main scope is to reduce the cost for end users. So we are using the main cell phone from the driver in order to enable both projects here, one for rear-end collisions and other for detecting potholes. So the cell phone from the user here acting as an important player for us, also acting as a gateway to connect to the cloud. And well, as I am almost in the final of my presentation, and considering the blockchain scenario, we have used blockchain in order to manage agrochemical products. So considering the supply chain of agrochemical products, we have the factory, of course, we have distribution centers, we have store, we have the final customer, and also we have the government agencies. So it's very important here because, okay, I am the final customer and I am buying agrochemical products, but after using these agrochemical products, I must go to a disposal location in order to deliver the bottle, for example. So it's very important to manage and to control all the players in the supply chain here, especially in our country, because in our country we have the industry of agro very developed. So in the right, we have our architecture, and we have mapped two kinds of blockchain networks. In the green box, we have a public sector blockchain layer, and in the yellow box, we have a blockchain layer especially focused on the private sector, and we have a connection between them. And in the upper layer, we have a knowledge layer, so working here with fog computing and data analytics. So we have some publications also together with Professor Dhananjay, together with us in this evening or in this morning in South Korea. And well, it's a pleasure for me as a researcher here at Unicinos and as coordinator of the Applied Computing Graduate Program also in the Unicinos. Well, it's a pleasure for me to maintain a healthy partnership with Professor Dhananjay and your university, and of course that's my idea to well, to continue our collaboration over the next years. So it was my presentation. Let me unshare here. Okay, and so we have a moment, Professor Dhananjay, for collaborations and, well, to answer some questions that we have from the audience. Well, I have present. I took note about some questions from you in order to understand your viewpoint about some topics, some hot topics. So, well, if possible, I'd like to see your viewpoint about interface. So, interface, connection between things, connection between vehicles. It's a very hot topic. So, I'd like to see your viewpoint. What could be the next IoT interface? What could be the next vehicle interface? Because it's very important to have a standard worldwide, but in the same time, I can understand that we have different purpose, right? So we have different scenarios. So we have like a paradox here, right? It's very important to have a standard, but in the same time, we have different scenarios and applications. So I'd like to see and your viewpoint about this topic.
Thank you very much, Professor Ricky, for introducing your research team and your research projects, software lab, and it was very nice and short description about your project. And regarding your question, right, what would be the interface for, especially I understand your question is what is the next IoT things? That is the main, I understand the point, what you are picking here, because lots of the experts and researchers, they are thinking what's next in IoT, right? So as you know that recently artificial intelligence is becoming boom, right? So now lots of people are talking about AI, and there they are using machine learning, deep learning kind of concept. So what I believe that the connectivity, AI and Internet of Things going to be combined together. And once they combined, so then based on the specific applications or the solutions, they can use for the interface. For example, if we are talking about the smart city, let's assume that we want to make a smart city project. So we need the connectivity, right? Where Internet of Things are associated, where we need internet connectivity for the providing the solutions for the publics and the consumer. So recently 5G and 6G researchers already introduced, and they claimed that they have already started using 5G network for the connectivity between the device, tiny devices with the big network. So they use cellular communication interface for that. But as for point of view, view from my side, as I just mentioned several times earlier as well, if we are thinking about IoT applications, we cannot depend upon cellular networks communication connectivity or their interface. It's my strong belief that if we are thinking 5G and 6G to provide solutions for IoT applications, it's becoming a very costly. Everybody is not going to use those kind of connectivity services as well, because they have to pay the bill. Yeah. So for in that respect, we need to find out some standard interface connectivity for the we can say the smart city, or we can say smart town, or we can say smart campus, whatever the peoples want to represent. And based on those, they have to build their own autonomous network architecture. And those network architecture has standard interface to provide several services within the autonomous campus as well. So if we, and as I just mentioned that the AI is going to be use very big role for everywhere, every aspects, because as we are knowing that earlier peoples was learning, but now machines start learning, right? So if machines are going to be learned, so we have to make them smart. So as you know that the recently one very connectivity as well as the AI solutions, then after they combine all to make the great impact for the society as well, to provide the good solutions and big business market. So just my point of view that the interface, it depend always, it based on the what kind of services we are going to use it. As just you mentioned earlier in your talk, like I think the food, no, agriculture support, there you mentioned about the 6 LoWPAN, device, right? And if you saw my talk was when I started my introduction, that time I introduced you our stack, IoT based stacks. So I introduced 3 stacks. So if you remember, there was the first stack was the 6-LoWPAN stacks. As you know that I have expertise on 6-LoWPAN stacks and implementation application, especially for IoT devices. So from there, the point of view, so 6-LoWPAN is the one, but nowadays there are lots of things already introduced. So based on the services, again, I will go with that. We can think about the interface. We cannot go still now. Lots of people are doing research, but there are no standard interface for specific technology. They combine all of things together, and then we can provide the solutions for the which field we want to consider for the. For example, if we are thinking about healthcare industry, or we are thinking about the agriculture industry, both are big difference, right? Healthcare, we need very high security network connectivity and a very strong power of the security services. But the agriculture case, we can be a lenient, right? Because here, because their supply chain management, we can use blockchain connectivity services, and then we can analyze the data when our crops are ready and it's ready for the urban area to support those kind of foods or vegetables, those kind of things. So we can use blockchain network easily for that. But if we want to go exactly solutions, so we have to implement IoT based agriculture field as well, to know the land, how much water in that, the foods, how much they are going to produce in next coming season, like that. So based on the services, again, I will come back to that. Over to you, Professor Rigi.
Yeah, perfect. Thanks, Professor Nanjai. Well, for your great explanation. So I completely agree with you. So, well, I can summarize that in the future, we will have different communication requirements for each kind of scenario. For example, we can have different latency usage, well, bandwidth, and also number of nodes, data size for agriculture or for vehicles or for healthcare applications and so on. And well, I believe that we will have a particular standard for each kind of application, so depending on communication requirements. So, but well, talking about the standard is very, very important because well, standard is important to use. It's important for us to use a particular technology worldwide. So our main standard today is web services. So we have client and a server and WSDL interface connecting them. So it's very important to have an interface API like this web services to IoT applications. But I think that we will go in this direction for the next years. So Professor Ranjai, continuing our great discussion here, I have other important issue here. Well, talking about networks, we are in the era of softwareization networks. So the idea is to use more and more software. In other words, we are migrating. Well, the idea is not more implementing hardware functions inside the hardware, but putting them in the cloud, putting them in containers or virtual machines. In other words, in a software layer. That's nice. The idea of management is very nice also. So we can orchestrate our functions easily without problem, and we can arrange our application in the same way. So software for networks is the future. But for me, the key problem is performance. Because why implementing in hardware? Because hardware is fast, is very, very fast. You understand? So in the future, can migrating all our functions from the hardware to the software, how about the performance in your viewpoint?
All right. So as I just mentioned that in the respect of the performance, still now we was thinking about the good performance. Actually, there are lots of issues based on IoT devices. Why we cannot see several applications in IoT devices? Reason is the performance issue. The low power embedded device, the size of the hardware is very, very small, so they cannot perform properly in the respect of connectivity or in the respect of computing power, they have very low computing power devices as well. So as I just mentioned earlier as well, so in the connectivity now, we are expecting AI going to be big role for this case. So artificial intelligence is going to combine over the computing power and then improve the performance of the specific particular services and the solutions as well. So AI is going to be very big role to improve the performance. And if we are going to implement the concept of that, then of course we are going to improve the performance, because as I just mentioned that we are teaching to the machines how to perform. Nowadays we are training the data, we are training the information, then based on those information they can have to be take action for next steps as well. So that is the very important things we can see about that. And second point here I just want to mention here, the improvement of the like connectivity. If we want to think about that, so that is the very big challenge, that's truly speaking, because lots of standardization going on in IoT field, but still now no standard platform where everybody is going to connect for the IoT applications and services. All researchers they are using their individual platform, they are using their individual framework to support for particular applications for that. And as I just you mentioned about the software, so as I you remember maybe previously we was working one project that called the software based layering, right, to establish the connectivity of the network. So what we do that we don't follow the TCP IP stacks, we was trying to make the software stacks tier 0, tier 1 and tier 3 based on those hierarchy architecture. Like first tier top tier is going for the application, middle tier is going for the services like security and the security purpose connectivity, those kind of, and bottom tier is going for the hardware equipment. So hardware going to connect with the application, so we need those kind of, and then we make the software for the specific hardware and then to connect for the specific services. So for the healthcare case we need different kind of hardware, for a factory for things we need different kind of hardware equipment, and then all combination based on the software layering. I just you mentioned the SDN, software defined networking. I just mentioned about the content centric networking. So those are also going to be very big role, because they are also based on the software layers to establish the connectivity between hardware and software as well, as you just understand, right?
Well, again, well, we have a great connection, Professor Dhananjay, and well, I agree with you. So in the future, I think that we will have, so not in the future, but also in the present, we have that. So we are experiencing the use of, well, virtualization tools much better so than ever. For example, we can perform virtualization without, well, existing bottlenecks that we had some years ago, and also by passing operating system delays. For example, today we have lightweight tools in order to work with orchestration, like Docker, for example. That's very useful when working with softwareization and implementing network functions directly in software. So network speed, as you said, and virtualization tools are very, very important for this next area of softwareization networks. So continuing our discussion here, we have a question from our YouTube audience. So, well, our workshop is live on YouTube, and we have a question. So this question is from Mateus Belchiades, and we have the following question. As IoT device and AI are becoming popular in health applications, how do you think computer science, health, and engineering will cooperate forward? I mean, how do you see these three areas cooperating even further academically?
All right. So as you know that the especially the computer science, and as nowadays, as you guys all know that, we cannot say only the computer science. Nowadays, all research based on interdisciplinary research, where computer science, electronics engineering, and electrical engineering, mechanical engineering combining together. All researchers are combining together, and even though the medical hospitals case as well, especially you just mentioned about the healthcare applications. So we as the engineers cannot develop the technology for healthcare industry. We must have to consult with the doctors. They are going to be use our healthcare related data for their specific purpose or not. Without their consent, we cannot produce the technology, right? So I mentioned before, we was involving healthcare monitoring applications project. So healthcare monitoring application project, like, so computer science engineer need to develop the strong big software to make more secure, but a similar electronics engineer has to make the sensors like ECG, PPG sensors to support those the software, and then the doctors who is going to analyze our data, real-time data collecting from body, so they have to approve those kind of information. Like previous our project, we was involved there. So we work software like computer science departments, electronics engineering department, because we need equipment, and then we visit to the hospital. Then doctor has to check and they give the approval. Okay, your device has this kind of issues, so can you improve this data in your software or your hardware equipment? So then we can after their approval, we can build the solutions for the specific or healthcare industry, as just you mentioned about that. So these, the combination, especially the interdisciplinary research, if you guys have heard about the biomedical engineering introduced. So biomedical engineering, usually they develop the device, healthcare devices. In our university recently, we started the new department where biomedical engineering department, so where we combined to teach the courses based on from the computer science, electronics engineering, and medical related issues as well. So you can understand all research which is going to provide the community services. We cannot only depend upon the one departments only, right? Now we all departments have to come together to produce the good solutions for that. Over to you, Professor, again.
So, well, in my opinion, I think that today we have another return way of interdisciplinary research.
Yes.
So, for example, in our group, we have collaboration with electrical engineering, medicine undergraduate program, biology. So a lot of course, so we can put more value for our research, and not talking only about value, but talking about solving problems, because
Exactly.
we are computing science guys, right? And we are not engineers, we are not physicians. So it's very important to join all specialists from different fields in order to present a better solution, as you said. So, here at Unicinos, I am the coordinator of the Applied Computing Graduate Program, and we are experiencing a new reality, because we have lectures in our course like Internet of Things, software engineering, and programming techniques, and we are receiving a lot of students, master and PhD students, from other courses like engineering, like medicine, like biology, and we are receiving them a lot because computer science is in the middle of the world today, right?
Exactly.
And so, we have a highlight for our research, because any kind of knowledge area today needs computer science. So, we are receiving a lot of students, master and PhD students in our courses, and this is a reality. So, for the future of research is interdisciplinary, and also I think that as computer science guys and as professors and as researchers, we must receive all of these people and present them what is a good practice on programming, for example, and also we must receive from them okay, I would like to understand technical details about engineering, or I would like to understand technical details about medicine, physician, and so on. So we have an exchange of information from the future, and we must exercise this much and much and much. That's our idea. So thanks our audience, in special the student Mateus Melquiades, for this question. So, Professor Dhananjay, do you have a question for the group, for me, and would like to discuss? Well,
Yeah, actually, yes, I was very impressed your one solution that you have used for the agriculture field for Industry 4.0, I think, project you use for the milk farming, right?
yeah, yeah.
What is that? Could you explain a little bit more how your idea it is? What is the main technology behind that?
So,
You want to connect the device over the like animal, or you are just collecting the milk storage capacity to distribution case? Where did you use that?
so well, we are using a standard device in order to collect the milk from the cow, right? And considering the amount of milk, and here we have a sensor in order to understand the level of the milk for each cow, right? And we have a sensor for that. And considering the amount of milk, we have a historical data considering the amount of milk, and we can, we can prepare a particular amount of feeding for a particular cow. For example, in this moment, I have a low level of milk for this cow, so it's very important for me to improve, to enlarge the amount of feeding for this. Or, for example, in this moment, I will trigger the farmer, okay, I think that this cow has a problem because the milk level is very low, for example. So we have two kinds of notifications in this research, and also we have a connection between the milk and the feeding for a particular cow, also working with data prediction. And well, working with data prediction, we are working with ARIMA, auto-regressive integrated moving average, because, for example, we could use, neural networks, random forests, or moving average. But in our research, ARIMA was the best option for us because ARIMA has a good assertivity, and also ARIMA has a very, very good performance. So we joined both assertivity and performance together in ARIMA. That's our research, and in particular, this research was very interesting for us because we have a real deployment on that, and also because it's very important to put value for the society in our research. So it's not interesting, okay, I have a research and I have a paper, but it's very important, okay, papers are important, but I think that you agree with me that we must deliver a value, a strong value for the society. So we must change the society for a better life. That's our mission as researchers, right?
That's true.
Yeah, that's it.
So, one more question here.
Yeah.
So, what kind of technology you are considering to analyze the particular cow or the buffalo has that much milk? Is there some sensors you are thinking, or the previous data last year, how much they have produced that milk, or what is the like technology behind that? How you are measuring that?
Okay. So in this moment, we are using RFID systems, right?
Okay.
In order to implement this, and considering the API technology, we are using GS1. GS1 is a standard institution, and we have a middleware named FastTrack. So FastTrack implements the EPC Global API, right? And so using this kind of API, you can check data from the calls. And in particular, we are using a particular sensor and a particular actuator for each call. That's very, yes, for each call. And well, if I remember, they are not so expensive. Well, RFID tag and RFID header is not so expensive today.
Very cheap, yes.
And well, considering the actuator engine, we have our colleagues from the electrical engineering helped us on developing a mechanism for opening and closing a particular door, right? And so we have feed for a particular call, and we can open and we can close for a particular time this door, and the feed is flowing to the call when the door is open. That's our main idea. That's a very simple idea of opening and closing a particular door for a particular call. That's our some details about our implementation.
All right. Very interesting. I really like that idea one that you have mentioned that. Yeah.
Well, going further, well, we have other question here from our audience. Well, one second. Uh, from Malaktala Nagamani, we have a question. Thanks a lot. So we have the following question. Do you have suggestions to beginners in a graduate program for, let me see one moment. So again, do you have suggestions to beginners in a graduate program for what kind of skill sets they should possess and how they can involve dimensions of research? So that's a good question, Professor
Yes.
Danekai. I'll go ahead.
Yes. Okay. Thank you for. Yeah, I know Professor Nagamani is asking. Okay, regarding the graduate program. So, see, mainly what I understand her question is that what kind of departments expertise they needed to study for graduate and research purpose. So again, I will say the what is the our core departments like electrical engineering, electronics engineering, and computer science department. These have very strong subjects before becoming to go for the research purpose. They have to build up their basic knowledge. So during the engineering course, any major during the undergraduate study, especially we recommend them to make strong basic knowledge about the technology and the basic knowledge about the concept, especially what they want to do in the research field or for their graduate study. I know so many students and the peoples who are doing research, but they have the fundamental level is little poor, so it's hard to produce the result for them. Of course, they can have very strong and good idea, but to it's a very hard time. So what I recommend that first build your strong basic knowledge about the specific field which you are interesting on that. For example, if you are interesting to develop hardware technology or you are interesting on hardware, study about the hardware circuit design, VLSI, and this kind of thing. If you are interesting to go for software field, learn about the programming. That is the very strong purpose for that. Of course, without mathematics, you cannot do anything. So
Yeah.
you must have to go for the basic concept about that. If you have this basic knowledge about the subjects, then I think anyone who has an interest to do research, he can produce good result for that. So especially for the graduate program, uh, generally in our country, we don't uh, ask the applicants which major you have done in your bachelor degree. Especially in Korea, we don't care what is your bachelor degree. Of course, it is help to check your background study, but every field, like if somebody, even though he is in different background and he can apply their graduate program in the like electronics engineering or computer science, it's free to apply and they can study on that. I think same system follow in Brazil as well, right, Professor Rigi? So
Yeah.
any major, anybody can apply any major in their graduate program, right?
Yeah. Right.
Right. So it doesn't matter for that. Yeah,
So
you have any some on that? You can also give your feedback in this topic because he's asking from India. So that question comes from India.
so well. a very nice question. So I will divide my answer here in two topics. Well, the first topic is how can I interact with a system? So in my viewpoint, we have three manners of interacting with a system. So we have a graphical manner, and so you have a command line manner. But in my understanding, the most important as skills so is using API, application program interface. So you must understanding how we can code a program for a particular technology. So it's not so important, so viable to use a system graphically or to use a system using command line, but you should program using API for a particular technology. So understand, learn the APIs for a particular technology, for example. That's one idea. And the other topic, of course, is AI. Artificial intelligence is widespread today, and well, artificial intelligence is like a vague topic. So artificial intelligence is in the same time all and nothing. So it's very important to understand what is AI. And as a researcher, I can divide, for example, in three main areas. For example, data prediction. And considering the idea of data prediction, and considering the idea of programming, you must focus, for example, on neural networks, random forest, moving average, ARIMA, and so on, in order to enable data prediction. And so the other branch on AI is event detection, pattern detection. And considering the idea of pattern detection, of course, we can work with k-means, or we can use KNN or support vector machine in order to enable pattern detection. And well, the final branch here on AI is data or event correlation. So we can establish a cause effect, a cause consequence effect here. And in order to code a program here, we can use correlation metrics, or you can use the Pearson coefficient, or we can use the causing technique. So it's very important to, okay, of course, I understand that AI is much larger than that, but it's important to understand prediction, data detection or pattern detection, and correlation, and how we can code examples like this. So talking about skills, that's my viewpoint.
Yes, you're right. And also, I just want to include here, as just you mentioned about that. So there are lots of research also going on in this field. So what I believe that AI has combined like two parts. One is the narrow AI, where is they focus about the application-oriented AI solutions for that, for X-ray analysis, the X-ray related data, IoT related data. So they go for particular applications. And one is the big general AI. So in the general AI has the intelligent things, for example, like they have to build the stacks to provide the services where machine learning, neural network, deep learning, this becoming as a subpart and tools to make the strong solutions for that. So the narrow AI they generally use for the specific purpose to build it, especially used for the IoT applications. What I just wanted to mention that. So IoT solutions, because IoT is only based on application oriented solutions, right? So there they use the narrow AI concept to produce the stacks and network services as well.
Yeah. So, Professor Dhananjay, I don't have much time. And well, it was a pleasure to receive you in our university. Thanks again for providing us one of the most interesting events in the Forum Brazil Korea. So in this moment, well, I'd like to pass you the token for your final considerations, Professor Dhananjay.
So as like formal, like my comments in this whole event, like as we all are working last several years, as just you mentioned that we are working Brazil, Korea, about 10 years, we have a collaboration, and then I think we should continue and collaborate in further upcoming hot topics where the researchers, both country, like from Brazil side and Korea side, they jointly work together and produce the solutions which can used by the Brazilian government side or Brazilian society, and also same things we expect for the Korean side for the test bed purpose initially, right? So we can use and test for test bed purpose. Then after we can go for the society services as well, because we are totally different zone, and it's one end and that is another end. So we have, I think, different prospects for the peoples or the who want to consider the technology and services. I think it's very good collaboration for the future, and it's also very good for the students who is joining and listening this our discussion. And from our side, if they are interested to visit Korea, they can join my team and my lab. They can work here few months, 6 months, 3 months, and then we can have more deep research collaboration on that. And also, like last year, you and your team already visited here. You guys, it was great time. You guys has here 2 weeks here, right? During that time, and then we had a collaboration and discussion. We had SALT workshop at our campus, and we met several professors from the Unicinos. So it was a great event also to hosting you all here. So we expect that if you have opportunity, then you guys can visit again here, and then we can have a lots of opportunity, and we can keep on continuing our Brazil Korea forum similar like that. And also in coming future, I'm looking forward to produce several more good results jointly with Professor Righi Labs as well. And of course, some of the project already going on. So hopefully we'll produce very good result in coming future as well. Thank you, Professor Righi.
Well, thanks, Professor Dhananjay. It was again a great pleasure for us to receive you. You and the faculty members of your university are always welcome to Unicinos. It was a great moment. So in the future, we can go further on advising and co-advising master and PhD students, and also we can apply for open calls projects together, right? And it's a pleasure, a great pleasure for me to have you as a great partner here from our group. So again, thanks a lot.
Thank you very much, Professor Righi. I just have one small discussion. Like recently, our one project going on, right? The Industry 4.0, right? The project we applied under that your team visited here. So that project, how long it is going to be? That's the project.
We have more 2 years in this project,
and so 2 more years.
Yeah, and you have scholarships both for PhD students and for visiting professors to go abroad.
Perfect. Yes. So under that project, you can send some students to our laboratory, right? We had discussed.
So I remember that. Perfect. So again, thank you, Professor Dhananjay, and thanks our audience from YouTube, and thanks our backstage team here that have promoted us this space for discussion here. Well, it was a great moment for our university, and so fortunately or unfortunately, I am closing this workshop. Thanks again. Bye-bye.
Thank you, Professor Regis. Bye-bye. See you again.